For as long as humans have looked up at the stars, one question has haunted our collective imagination, echoing through the halls of science and the pages of fiction alike. Are we alone? Is this pale blue dot the only spark of consciousness in a cold, indifferent void? Or is the universe a vast, hidden garden, teeming with life in forms we can barely conceive? For centuries, this was a question for philosophers and poets. But today, it has become one of the most rigorous and exciting frontiers of modern science. We are no longer just wondering, we are hunting. We are scanning the heavens, listening for whispers in the radio static, and probing the frozen moons of our own neighborhood. The search for extraterrestrial life is the ultimate detective story, and the stakes are nothing less than our understanding of our place in existence. To begin this search, we first have to ask, what exactly are we looking for? For a long time, our search was Earth-centric. We looked for liquid water, oxygen, and moderate temperatures, the ingredients that allowed us to flourish. We call this the habitable zone, or the Goldilocks zone. But as we explore the extremes of our own planet, we are learning that life is far more resilient than we ever imagined. We have found extremophiles organisms thriving in the boiling vents of the ocean floor, inside solid rock, and even in the high-radiation cooling tanks of nuclear reactors. This has blown the doors wide open. If life can survive in the most hostile corners of Earth, why couldn't it exist in the methane lakes of Titan or the subsurface oceans of Europa? The search begins close to home, in our own solar system. For decades, Mars has been the primary target. We see the dry riverbeds and ancient lake basins, clear evidence that the red planet was once a blue world, warm and wet, billions of years ago. Our rovers, like Curiosity and Perseverance, are currently prowling the Martian dust, not just looking for water, but for biosignatures, the chemical footprints of ancient microbial life. Every drill sample and every panoramic photo is a message from the past, whispering the possibility that Earth was not the only world in this system to experience a biological awakening. But Mars is just the beginning. Some of the most tantalizing prospects for life aren't planets at all, but moons. Deep in the outer solar system, far beyond the sun's warmth, lie the ocean worlds. Jupiter's moon, Europa, and Saturn's moon, Enceladus, are encased in thick shells of ice. But beneath that ice lie global oceans of liquid water, kept warm by the gravitational tug-of-war with their giant parent planets. We have seen Enceladus shooting giant plumes of water vapor and organic molecules into space through cracks in its ice. We are preparing missions like the Europa Clipper to fly through these plumes and taste the water of an alien ocean. If there are hydrothermal vents at the bottom of Europa's sea, similar to those on Earth, there could be entire ecosystems thriving in the total darkness, independent of sunlight. Beyond our solar system, the search enters the realm of the exoplanets. As we discussed in our previous episode, we have discovered thousands of worlds orbiting distant stars. But finding a planet is only the first step. The next great challenge is atmospheric characterization. Using the James Webb Space Telescope, we can now look at the light filtering through the atmosphere of a distant planet. We are looking for unnatural balances of gases methane and oxygen existing together, for example, which usually requires biological processes to maintain. If we see a planet with an atmosphere rich in oxygen and water vapor, it would be the strongest hint yet that we are looking at a living world. But what if we aren't looking for microbes? What if we are looking for someone like us or someone far more advanced? This is the domain of SETI, the search for extraterrestrial intelligence. For over 60 years, Astronomers have been using massive radio telescopes to listen for signals that don't belong to the natural background noise of the universe. A pulsed signal, a narrowband transmission, or a geometric pattern, any of these would be a definitive hello from the stars. So far, the great silence persists. We have had tantalizing moments like the famous wow signal in 1977, but nothing has been confirmed. However, the search for intelligence has evolved. We are now looking for technosignatures. These are the physical evidence of advanced engineering. Imagine a civilization so advanced it builds a Dyson sphere, a massive shell of solar panels around its star, to capture every drop of its energy. Such a structure would emit a specific infrared signature that our telescopes could detect. We are looking for the glow of alien cities, the chemical traces of industrial pollution in distant atmospheres, or even massive satellites orbiting other planets. We are looking for the artifacts of a cosmic neighborhood that might have been inhabited for millions of years before we even learned to walk upright. This brings us to one of the most profound and unsettling concepts in the search for life: the Fermi paradox. Named after physicist Enrico Fermi, it asks a simple question: where is everybody? Given the age of the universe, 13.8 billion years, and the sheer number of stars and planets, there has been more than enough time for a civilization to colonize the entire galaxy, even at sublight speeds. So why don't we see them? Why hasn't a probe landed on our lawn? There are many proposed solutions to this paradox. Some are hopeful, others are terrifying. Perhaps life is common, but intelligence is a rare evolutionary fluke. Maybe civilizations inevitably destroy themselves once they discover nuclear power or artificial intelligence, a concept known as the Great Filter. Or perhaps, in a dark forest scenario, the universe is full of civilizations that are staying quiet and hidden out of fear of predators. Another possibility is that we are simply too early. Earth might be one of the first habitable planets to emerge in a universe that will continue to host life for trillions of years. We might be the ancients that future civilizations will one day wonder about. Despite the silence, the Drake equation gives us a framework for hope. Created by Dr. Frank Drake in 1961, it's a mathematical formula used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way, while many of its variables are still guesses. It reminds us that even with conservative numbers, the probability of us being alone is staggeringly low. If there are 200 billion stars in our galaxy and almost every star has planets, the biological potential of the universe is almost infinite. The search for life also forces us to redefine what life actually is. We are biological, carbon-based, and water-dependent. But could life exist based on silicon? Could there be shadow biospheres that use arsenic instead of phosphorus? Or more radically, could the most common form of life in the universe be post-biological? If a civilization survives long enough, they might upload their consciousness into machines or create sentient AI that can survive the harsh vacuum of space and the vast timescales of interstellar travel. When we finally make contact, we might not be talking to a biological being, but to an ancient, immortal silicon mind. The implications of finding even a single alien microbe would be the greatest shift in human history. It would represent the second Genesis. It would prove that life is not a miracle unique to Earth, but a standard feature of the laws of physics and chemistry. It would tell us that the universe is a place that wants to come alive. It would change our religions, our philosophies, and our understanding of our own future. It would be the final nail in the coffin of our self-importance. but it would also be the ultimate validation of our curiosity. But what if we find nothing? What if, after centuries of searching every moon, scanning every frequency, and analyzing every atmosphere, we find only silence and sterile rocks? That too would be a profound discovery. If life is truly unique to Earth, it would make our planet infinitely more precious. It would mean that we are the only part of the universe that has opened its eyes and started to think. It would give us a cosmic responsibility to protect this flame of consciousness and spread it to the stars. The search continues because we are a species of explorers. From the first humans who crossed the land bridges to the astronauts who walked on the moon, we have always been driven to see what is over the next hill. Now, the next hill is the light years between stars. We are building bigger telescopes, launching smarter probes, and refining our theories. We are on the verge of knowing. Within the next 20 years, we may have the first definitive evidence of water on a habitable exoplanet, or the first chemical signature of life in a Martian cave. This quest is about more than just finding them. It's about understanding us. By looking for life elsewhere, we learn what makes our own world so special. We learn about the delicate balance of our atmosphere, the protection of our magnetic field, and the incredible luck of our planetary history. Whether the universe is a crowded marketplace of ideas or a lonely cathedral of stars, the act of searching makes us better. It unites us as a species, looking outward together rather than inward at our differences. As you look up at the sky tonight, don't just see points of lights. See potential homes. See distant oceans, alien suns, and the possibility that somewhere, at this very moment, someone else is looking at a tiny yellow star in their sky, our sun, and asking the exact same question. Is there anyone out there? The answer is waiting for us, written in the light of the stars and the dust of the planets. We just have to keep looking. Thank you for joining us on this profound journey into the greatest mystery of all. The search for life is a marathon, not a sprint, and every day we are getting closer to the finish line. If you want to stay updated on the latest discoveries in astrobiology and space exploration, make sure to subscribe and turn on notifications. We have many more worlds to explore and many more mysteries to solve. Until next time, keep your curiosity alive, keep searching the stars, and remember, the universe is a very big place, and if it's just us, it seems like an awful waste of space. Safe travels, fellow explorers of the infinite.